All right, our next talk, we have Yuk-Jin Kwon and Alan Faulting. They are going to give a talk about scaling pandas to any size with PySpark. The stage is yours.
Thank you so much.
Thank you.
And welcome, everyone. So don't worry too much about the confidential and proprietary. I forget, that was just a template we used. None of this is actually confidential. But yeah, my name is Alan Faulting. I'm a product manager at Databricks, primarily focused on PySpark, also working on a few other projects. And
I'm Hyuk-Jin Kwon. I'm a staff software engineer at Databricks, and then I'm a Apache Spark PMC member and committer. I'm leading the open source PySpark team in Databricks, and then I'm the top contributor in Apache Spark.
Thank you. Yeah, and today we're going to talk to you about pandas on Spark, basically. So a quick look at the agenda. First part is about what I just said, Pandas API on Spark, how to scale your workloads using the familiar syntax of Pandas. Second, we're going to walk through Pandas UDF and Function API, so you can write distributed UDFs. And lastly, I'm going to give a brief introduction to the English SDK for Spark, which is an LLM-based way to work with your data. So I think we all know that Pandas is everywhere, it's ubiquitous, and it's very popular. Whether you like every detail of it or not, it is a fact that it's everywhere. I think last year I read that at that time Pandas was just as popular as Python was 6 years earlier. And so, super popular framework, so of course we care about it. But what if your workloads are large? How do I scale? Well, there's a couple of options. You can buy a bigger machine. You can downsample the data, which kind of defeats the purpose of working with large amounts of data, but you can get some work done that way. Or you can switch to a distributed data processing framework, which is the focus of this talk. And so just a brief introduction to Spark. Spark is a distributed processing engine, and this is just a typical view of what that looks like. So you send your workload, your query over to the Spark driver, and it makes decisions around how to actually execute that. And when it can parallelize the work and do pieces of the task on different nodes, it'll do so. And as you can see with the cores and tasks indicated here, work will be allocated on an available core. And then it'll run, and when it's all done, it'll be merged back up and aggregated to the final result. So just a quick overview of how that works. And of course, you can run things faster that way when things are very large. But this Pandas API on Spark that we're about to talk to, is that really necessary? We have PySpark in the Spark community. Well, the difference, the issue here is that the syntax is different. This is just a simple example at the top with using pandas and a PySpark example at the bottom. And there's a good amount of differences. Not that you cannot learn it, but it's still an adoption curve for the end user. So how can we get around that? How can we avoid that? People need to learn PySpark.
Yeah, so that's why we introduced the Pandas API on Spark. The Pandas API on Spark was first introduced as a class. So you can use the same API, the Pandas API, and then you can run on the Spark cluster. And then this was merged into the PySpark because it became more and more popular, and then the users don't like to install the separate library. So it was like merged into the PySpark. So you can run the Pandas API on Spark by replacing the one import line, and then it supports the 80% of the Pandas API for now. All right. Nevertheless, there's some difference between the Pandas data frame and then the Spark data frame. Before I'm talking about how we implement Pandas API on Spark by using PySpark data frame, there's a bit of difference. For instance, the Pandas data frame is mutable. So for instance, you can update the series within the data frame, right? You can change the value within your Pandas data frame. But PySpark doesn't allow this. Whenever you operate something, then it creates a new PySpark data frame. This was actually inherited from the characteristic from the RDD, that is the core of the Apache Spark. So because of this difference, we have the syntax difference too. We copied this Pandas API behavior by having another layer called internal frame. So in end user's perspective, it allows the mutable operation, but under the hood, we have the one layer that's called internal frame, and then it makes a copy under the hood. But since the pipeline, allows the get attribute or something like that, right? So the new copy happens within those methods. So in end user perspective, it looks like a mutable. So this is how it works. So yes, it works good. When the number of the node grows, the performance linearly the performance improvement is linearly growing too. And then the API coverage is also pretty high, like around 81%. But it will never reach 100% because there are some API that doesn't make sense in a distributed computing. For instance, there's a like memory info something, but since the Spark is lazy execution, you operate something, but nothing actually happens within your memory. So this kind of API wouldn't be able to be implemented. All right, so I'll just, this is most common question that users ask. In Pandas, you have the default index, right? For instance, you create a data frame, then it creates a range index by default if you don't provide. This is easy because within one node, it's easy to just create it in one sequence, right? But it's a bit challenging in the distributed, the distributed environment. There are 3 types of such index created in the Pandas API on Spark. The first one is sequence. This is exactly compatible with the Pandas range index. But this creates the index within the single node. So if, of course, the data is like large, then it will go out of memory. So you can just use it like for like simple testing purpose. Second one is the distributed sequence. It uses the group by and group map approach. So yes, it requires a shuffle, but distributed, and then it is also compatible with the range index in Pandas. Third one is the distributed. This is not compatible with the Pandas index. It will, yes, create an index that increase somehow in end user's perspective, arbitrarily growing, but unique. But this doesn't require a shuffle, so this is most performant one if your Pandas workload is not dependent on the index operation. All right, so should I use Pandas API on Spark, or should I learn PySpark? I have a very short answer. If you know Pandas already, and then you want to scale it out like bigger data like right away, then just use Pandas API on Spark. If you're interested in learning PySpark, but you want to use the machine learning or structured streaming or other features like history server or different server, then it's probably the PySpark is the good option for you. All right, so far I talked about the Pandas API on Spark. So that we compose the Pandas API on the top of the PySpark, right? But this chapter is a bit different. Let's say you want to integrate and then use the native Pandas instance. For instance, the scikit-learn, like the Pandas data frame, Pandas API on Spark doesn't work magically with scikit-learn. So you need the Pandas native instance, for instance. Then how do I scale this up? We have some friends for that in PySpark. That's Pandas UDF and then Function API. All right, so we have friends. The Pandas UDF is that I wrote down like many contents, but you can just think that like it's column-wise option. Let's say you want to transform the value a column from A to B, then it's just it's Pandas UDF. And then the Pandas Function API is data frame. I would say table-wise operation. For instance, join, sort. They operate something within the table. So this is the example. So Pandas UDF, it takes a service, and then roughly speaking, the concept of service is mapped to the column, right? So you annotate the column, and then it will take that as an input and then output. In the Pandas Function API, you take the, of course, data frame as input, right? Because it's table-wise operation. I'll talk a little bit more about the Pandas UDF and then Function API. So annotate for Pandas UDF, you gotta annotate, and then what you want to take as an input and output. So for instance, in the example below, I type the Pandas series, take as an input, and then output as a series. And then PySpark will decide how to execute under the hood. They are, of course, serialized, deserialized, and executed in a vectorized manner. I'll show you a couple of more examples. For instance, second one, I typed annotate input as a series and the output as a primitive int, meaning that it will end to 1, it will aggregate something. Then PySpark will understand this and then execute based on the type hints you provide. Whereas Pandas Function API, you can optionally annotate the type, but it's not required. It depends on which API you invoke. So you call the API, and then PySpark will decide how to execute based on which API you invoke. And then they are, under the hood, they are executed in the same way with the Pandas UDF. So these are examples. So in the first example, you code group by and then apply in Pandas. Second one, as you can see, we are calling co-group. And then last one is calling the map in Pandas API. So why is it different, the Pandas UDF and then Pandas Function API? It's related to the design. So, I mean, I don't know how many have you read the SQL paper, but there's the Pandas Function API is mapped to the query plan. And then the UDF is mapped to the expression. And then the SQL query plan can have a arbitrary expression, but this query plan usually has a distinct purpose. So it's mapped to the design. All right, so this is one common question I get for using the Pandas UDF and the Pandas Functions API. Out of memory, especially when you use the grouped Pandas Function API, for now, the whole group is into the memory. So let's say your data set is skewed, and then the whole group is into the memory, then you might see the out-of-memory exception. There's a technique called salt. So it's basically the partial aggregation. You add a 1 hash column, and then you aggregate it once, and then you aggregate that again, meaning that the size of the computing group is smaller. How to use it in an actual example? As you can see, I added a column called salt here, and then aggregate it, and then I aggregate it one more time. So you can avoid the out-of-memory by using the partial aggregation technique. All right, so there are a bit of tips about the performance and debug. We PySpark provide the remote debugging mode, where you can work with the PyCharm. We have memory profiler, so you can see the line by line which line consumed how much memory. And then, of course, yeah, we gotta avoid the for loop. I mean, if the things can be vectorized. And then you make sure the repartition and then the data are properly partitioned. And then this is the way I like to use. You just print, of course, and then see what's wrong, and then print AAA, print BBB, and then see what's going on in the Spark UI tab. All right, that's the Pandas related things, and then I'll leave it to Alan.
Thank you. I'll give you a quick introduction to the English SDK for Apache Spark. And this is really a little bit orthogonal in the sense that with this API, you don't have to write either PySpark or Pandas code. You can get started with English language. And so what is it all about? Well, think of it as your source code, quote unquote, is English. Your compiler, again in quotes, is generative AI, some language model. And your bytecode is PySpark or SQL behind the scenes. By the way, the reason we are looking into this is, as you can probably imagine, to broaden the user base of doing data analysis at scale. So you don't have to be very knowledgeable in different programming languages. So what is it? What is in this SDK? Well, you can, in its current state, you can create a data frame from a table on a web page. You can do a bunch of different data frame operations. You can do transformations on a data frame, whatever you'd like to do. You can explain the data frame, how it came to be, based on your transformations. You can plot it, typing in an English sentence. And you can write verification code if you, for example, want to make sure that your data frame doesn't have nulls in a given column or something like that. You can express that in English, and the SDK will generate PySpark code to do that. It can also help you make user-defined functions. You provide the signature and an English sentence as to what you want the UDF to do, and it generates, again, PySpark code to do that. And lastly, if you're running the same English language queries many times, it has caching, so you don't do a lot of large language models calls, which cost you money depending on which model you're using and where. So you might ask, how is this different from all these other assistants and Copilot and whatever else you see out there today that is leveraging generative AI? Well, it's different primarily in the way that it returns a PySpark object, like a data frame, basically. And so in these traditional methods, which are super helpful, by the way, I'm not taking anything away from that. It's a little more step by step. You have to actually view the code and think about it. You can't just run it, but you're going through the process of creating it, like you see here on the screen. If you use LangChain directly, similarly, it's not going to send you back a data frame that you can keep working on in your environment. It's going to give you an answer to whatever you ask it to do in this way, as I'm showing on the screen. And then very quickly, the cache is an in-memory cache. You can choose to persist it on disk if you want to, and it's really all about being able to kind of fix an answer and say, you know what, the answer I got when I asked this question is what I want to stick to. I don't want it to randomly be creative and change the answer to that. And then also, of course, save money by not calling the model behind the scenes if it's outside your own domain and cost you money. But let's take a quick look. Here's just a little slide you can look at later, which is the small demo I put together to show you this a little bit in action. And so I'm not going to walk through all these details, but I'm running it all on this laptop, Spark, and a simple little application I wrote that's using this API, and these are the things you need to do to get that going if you want to. So here's it's not nice. It's a very quick mock-up. It's a little bit of a web app that doesn't do very much, but it has a few buttons and some prompts. So let's just start by taking a quick look at what I have here. So I have this fairly small program here, which is just a Shiny application, so Shiny for Python, where, of course, the majority of the code here is just setting up the screen, adding the various controls and text boxes, etc. And I have a little bit of code down here and up here, functions that are calling, for example, here I have a transformer function that's using the English SDK to do the transformation. And it's very little code on my part, but that's what's behind this. And so if I can just start by running this. Hopefully it works. I just said, show me the data. Super simple. And what it's going to do is it's going to go ahead and you can see how it reasons about this. And then you'll see the result in the application on the other side of the screen. But what if I want to see, I don't know, show the top 10 artists. This is a data set of music artists being played on the radio and how many times they've been played. Show the top 10 artists by number of listeners or something. And you can type whatever you want, obviously, here, and that'll give you more or less great results, depending on what you're doing. But we're in the process of making this much stronger and better at answering questions. And so, see, it has a thought, it looks at an action. We're using the React framework, if you heard about that in generative AI, which is about reasoning and acting together as opposed to only reason or only act, which has been the traditional methods. And I'm not going to go deep in that because we only have 1 minute left. But anyway, here's an example of the top 10 list of total listeners, and you'll see it did it with a group by and a sum, as you can imagine. And so what if I want to pivot this Pivot in Spark is a little bit more complicated because Spark happens to not support, like many other vendors don't, dynamic SQL in the pivot in clause. And so that's kind of typically a two-step thing. I first need to figure out the values that I want to pivot on, and then I can pivot. And so how does this framework do this? So let's say we want to pivot this on artist. And this is, oops, if I could spell. It's a little bit more of a complicated question in a way, because you can't just write one query. You first need to figure out what the artists are. And so this React framework that we added recently to this API allows us to do, like as you can see on the screen, it's reasoning about how might I solve this. Well, I know that Spark doesn't support this particular feature. So what if I send a query to first get the distinct list of artists, and then I can pivot based on that in the second query. And as you see, that's what it did here on the other side. And lastly, I'll click this explain query while I talk. So explain is all about, as I mentioned earlier, is all about giving you a human-readable explanation of what you did. This is a super simple demo, but in a minute this can be a little slow. There you go. It's going to put out this summary that gives you a sense of what exactly just happened here, right? So it can help users better understand output and things like that in some scenarios. The last thing, just going to reset the data frame and get the show and wrap this up. Get back to the beginning because I have more data to work with. The verify query could be something like, I could say, make sure there are no, super simple, rows without an artist. So no nulls, right? Or if I could again spell, it would be a little bit better. And I can click verify query in this simple application, and then hopefully you'll see it generate some Python code that I can then take and add for a validation step in my application. And it actually runs it and see it return true in this case. And this is the actual Python code over here. Anyway, quick intro, 2 minutes over time. I'm going to stop here and to the English SDK. We would, of course, love to have more people in the world contribute to this open source project. So if you have any interest, also just if you have any feedback, not just here at this conference, but afterwards, we would love to hear it. This could go in many directions. It's in some ways an experiment, but we're already seeing some tractions out there in the world with people trying to build things with it. But it's super early. This was very recently created, so that's that. Let's go back. Yeah, that wraps up our presentation. Okay. Like this.
So thank you so much for your talk. Are there any questions that you guys want to?
Thank you for this great talk. I'm just wondering, how is this tool aware of the database structure? Is it like scan on fly, or it's scanned each time? Like, how do you know how your fields are named, how to retrieve data from English language that are in the database?
So you're asking about the English SDK, right? Just to be so the way this works is that, and you can go look. It's open source. You can go look at exactly how it's built if you want to know more. Is that it's built around a data frame, and so we send over the metadata of the data frame, the column names, the types, and all that stuff to the model as part of the prompt engineering process. So we basically tell it what it has to work with. Does that make sense?
Okay. More questions? There on the back.
Thank you for the talk. One question about the LLM stuff. How deterministic are the queries that come out of the English? How do you handle versioning over time? Like, what if you upgrade and you get a new model? Am I going to get different queries?
Yeah. Yep. So that. Oh, did you have more?
No.
Oh, so that is a really great question. So, number one, so you can use different models behind the scenes. In this demo, I was using GPT-4 from OpenAI, right, which is, as you know, pretty popular in the world. You could use other models. LangChain supports other models, and we're using LangChain behind the scenes, as you may have noticed in the demo. And so supposedly, GPT-4 should be, I'm going to say, fairly deterministic if you set the temperature to 0. The creative factor, if you will. It should be pretty consistent, but like you just said, things can absolutely change. That is a problem in this space, and of course, one solution that we have that isn't a real solution for all scenarios, but is the cache, right? So you can turn on the caching and you can persist it and make sure that at least for a period while you have not yet validated new code or English, you could just use the cache and then get the same results that way, of course, because then we record the English sentence and the SQL behind the scenes or whatever we generate. But it is. I mean, these models are not deterministic typically, right? That is a fact. So, yeah, there's creativity here.
Great, thank you.
All right, we have still time for one question. No? Okay. You can talk with them later. Thank you so much once again.
Thank you.
Another round
Thank you.
of applause, please.